Hi everyone, in this video I'm going to go through some test questions from a trig test written at Rustenburg Girls High School. These questions will focus on two areas of trig, that is trig equations and 2D problems. If you're watching this video for revision, you may wish to pause it and try the questions before we get to the solutions. Here are the questions on trig equations. Then we'll go through some questions with 2D trig. These are fairly straightforward ones. Next, we'll go through a little bit more challenging trig 2D questions. These ones involve variables. The next question is proving the sine rule, which is bookwork and something you should learn for tests. And finally, as a little bit of extension, we'll go through a challenge question, which is based on question 3. Let's get going. The first question is a trig equation. I want to solve the equation for a specific interval. I want only values between negative 180 degrees and 180 degrees. So what I'll do first is I'll solve the trig equation giving a general solution, and then I'll use that general solution to find the specific solutions. So firstly, let's rearrange this equation. So I have 7 sine x, subtract 2 from both sides gives me negative 2. And then to isolate the sine x, I'm going to divide both sides by 7. Now, I like to use the reference angle method. So if I take out my calculator and work out the reference angle, I'll say shift sine, and I'll use positive 2 out of 7, and I get 16.60 degrees. Now, since my ratio is negative, I'll be working in the third and the fourth quadrants because that is where sine is negative. So in the third quadrant, I'm going to have that x is equal to, the rule for the third quadrant is 180 plus my reference angle, and I add a repeat of 360. Because with a sine graph, your period is 360, and so the answer will repeat itself every 360 degrees. And so what that gives me is 196 degrees, 0.6, plus a repeat of 360. Or I'm going to have an answer in the fourth quadrant, and the rule for the fourth quadrant is 360 degrees minus my reference angle, plus my repeat of 360. And so what I get here is 343.4 plus my repeat of 360, and that repeat is an integer. What I've given is the general solution, but they want me to give a specific solution for between negative 180 to 180. So if I go to my first general solution, I've got 196 plus a repeat of 360. If k was 0, I would have 196, which is too big. So let's try k being negative 1. In other words, I'm subtracting 360 from 196. When I do that calculation, I get that x is equal to negative 163.4. I can see if I subtract another 360, I'm going to end with a value that is less than negative 180. So I'm not going to go lower than that. Let's look at the solution in the fourth quadrant. 343.4 is too big. So if k was 0, it would be too big. So let's try k being negative 1. So I'm going to subtract 360 from that, and I get x is negative 16.6 degrees. Now, if I subtract another 360, I'm going to end up with a value that's too small. So my final solution for x is an element of negative 180 degrees to 180 degrees, x will equal to negative 163.4 degrees, or negative 16.6 degrees. And there you go. The next two questions we look at ask for general solutions. So in this question, we want to find the general solution for sine of 2x is equal to cos of x minus 60. Now, when you have mixed ratios of sine and cos, you have an option. Either you can try and make your sine and cos into a tan, but you can only do that if your angles are exactly the same, which they are not. Otherwise, you have to use one of the reduction formula. Now, the reduction formula I'm going to use is I'm going to change my sine into a cos. And so on the left, I'm going to say cos, and the way I do that is by saying 90 minus 2x. That will be equivalent to sine of 2x. So I get cos of x minus 60. So my reference angle is 90 minus 2x is equal to x minus 60. Now, since both ratios are positive for cos, I'm going to use the first quadrant or the fourth quadrant. So in the first quadrant, that's fairly straightforward. 90 minus 2x is equal to x minus 60, and my period for cos is 360 degrees. In the fourth quadrant, I'm still going to have 90 minus 2x, but the rule for the fourth quadrant is that I'm going to say 360 minus x minus 60 plus my period, 360. Now, it's important that you put your x minus 60 in brackets, otherwise you're going to forget to subtract the 60. So now I'm going to just do some rearranging. So let's bring the x's left. In other words, I'm going to add x to both, no, subtract x from both sides, so I get negative 3x. And I'm going to subtract 90 from both sides, so I get negative 150 plus my repeat of 360. And let's divide everything by negative 3. So I get x is equal to positive 50, and 360 divided by 3 is 120, and I can say plus 120 because k is an integer, and it doesn't really matter whether I'm adding it or subtracting it, because I'm going to end up with the same repeat. So let's take a look at the solution in the fourth quadrant. Let's first sort out that bracket. So I get 360 degrees minus x plus 60 plus my repeat of 360. And let's bring my x's to the left. So I'm going to add x to both sides, so I get negative x is equal to 360 plus 60 is 420, and 420 minus 90 is going to be 330 plus my repeat of 360. And so I get that positive x is negative 330 plus a repeat of 360. And that's my general solution. Oh, I forgot to put down that k is an integer. Now, as a little side note, there's another way to consider the fourth quadrant. Some people rather choose to use, instead of saying 360 minus your reference angle, they'd rather just say that I'm going to use the negative reference angle. And it works out exactly the same. So let's quickly see. I'm going to get 90 minus 2x is negative x plus 60 plus my repeat of 360. Again, I get negative x. On the right, I get negative 30 plus a repeat of 360. And so I get x is 30 plus my repeat of 360. Now, although the answer looks different, they are actually the same, because if I was to say 30 minus 360, I get negative 330, which looks the same as the previous solution. So these two solutions are actually exactly the same. They just start at a different point. So let's get on to the next general solution question. We've already done 2.2.1. So 2.2.2 has 3 cos squared x on the right, and on the left 2 minus 5 cos x. This could be a potential trinomial. So let's take everything and put it on one side. And that is a trinomial. So let's take a look at the structure. If I had cos x as k, I'll have 3k squared plus 5k minus 2, and that could definitely factorize 3k and k. I'll have to have plus 2 and minus 1. So if I factorize that with coses, 3 cos x minus 1 is equal to cos x plus 2 is 0. So either 3 cos x minus 1 is 0, or cos x plus 2 is 0. Therefore, cos x will be a third or cos x will be -2. Now we know that for the cos ratio, I have to have a ratio or a fraction that is between -1 and 1. So having -2, it will not be possible, so this here will be no solution. So let's just deal with the cos of x is equal to 1/3. Our reference angle will be 70.53. I used my calculator to work that out. And so since cos is positive, I'm dealing in two quadrants, the first quadrant and the fourth quadrant. So in the first quadrant, x will be 70.53 plus my repeat of 360. And in the fourth quadrant, x will be 360 degrees minus 70.53 plus my repeat of 360. And that gives me 289.47 plus a repeat of 360. And k is an integer. Just remember what I said in the previous question. Another way to write the fourth solution quadrant would be to say x is equal to -70.53 plus a repeat of 360. So either of those two solutions for the fourth quadrant will be valid. The next few questions we're going to look at are about 2D trig. Now, if you have access to an information sheet in a test or an exam, you'll see that the formulas you'll need are down here. Let's take a quick look at them. So the three formulas are the sine rule, the cosine rule, and the area rule. These three rules can be used for any triangles. Also, remember in the rules, the lowercase letter refers to the side opposite the angle, and the uppercase letter refers to the angle. The rules can be rearranged. So for example, the sine rule could be written as sine A over lowercase a is equal to sine B over lowercase b, as long as you follow standard rules of maths. Now for right-angled triangles, remember that you can use SOHCAHTOA, meaning that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, and also that the area is half base times by your perpendicular height. And these rules only work in right-angled triangles. However, your sine, cosine, and area rule can be used in any triangles. In this question, I have a sketch. BC is 3, AD is 8, DC is 4, and BCD is 120, as well as my sketch says that angle B, or angle ABD, is 90, which is not in the instruction. So 3.3.1, calculate the area of BCD. I'm going to highlight BCD. Now, BCD is not a right-angled triangle, so I can't use the rule half base times height, but I could use the area rule. Now, the area rule for 3.1.1, the area is normally half AB sine C. Now, let's consider the triangle I have and the information I've been given. Line BC is known as side lowercase d because it's opposite angle D. And line CD is known as lowercase angle b. And I have angle C. So my area will be half BD sine C. It seems like I have all the information I need, so all I can do is substitute. B is 4, D is 3, sine is 120. Put it into my calculator, and what I get is 3√3 meters. And it'll be meters squared because it's area. Okay, next question. Show that BD is √37 meters. So BD is this line here. Now I can't use the sine rule because I don't have any pairs of side and angle opposite, but I could use the cos rule. So 3.1.2, this will be side lowercase c. C squared will be b squared plus d squared minus 2bd cos c. And I have all of these values. So 4 squared plus d is 3 squared minus 2 times 4 times 3 times cos 120. If I use my calculator, I get 37 here. But I don't want c squared, I want c. So c will be the square root of 37 meters. The third question, 3.1.3. Determine the size of angle DAB. Now DAB is this angle here. It looks like I'm working in a different triangle. So in this different triangle, I know that side C or side BD is root 37. Even if I didn't get the answer that BD is root 37, I can use it because that's what the answer of the previous question should be. Now, since B is 90 degrees, I can use the ratios instead of using the sine, cosine, or area rules. So I want angle A. According to angle A, AB is adjacent, AD is the hypotenuse, and BD is opposite. So what I have is opposite and I have hypotenuse. And the ratio that uses opposite and hypotenuse is sine. So sine of A is opposite over hypotenuse. And remember, I can use these because I have a right angle triangle. So sine of A will be root 37 out of 8. And using my calculator, I can get that A is 49.49 degrees. As a side note, I won't have an ambiguous case here because I've got a right angle triangle. I've got the right angle, I've got the hypotenuse and a side. I have a case for congruency. So there's only one possible triangle that could be created, which means that there's only one possible angle for A. In this question, it says in the figure below, PQRS is a square with side length x. Now, when I'm told a fact about a quadrilateral, I always put the extra information into my sketch. So if PQRS is a square, that means all the sides are equal. Also, I know that my corner angle is 90, and the diagonal will cut my corner angle in half, meaning both of those angles are 45, or if I look at Q, both of those are 45 too. Point T lies on diagonal SQ, and the angle RTQ is theta, and all of that is on the sketch. So let's get to answering the questions. 3.2.1 says, what is the size of angle RST? RST is this angle here. And I can see straight away that it is 45 degrees. So 3.2.1, RST is 45 degrees. And let's add a reason in. Diagonals of square. Okay, next one says show without a calculator that TR is equal to x over root 2 sine theta. So the side length I'm looking for is TR, which is this side. Now I've got a few triangles I can work with. The triangle at the moment that has the most information is TSR, and I've got a side and an angle, and I could work out the other angle of angle T by using angles on a straight line. So let's say 3.2.2, this angle here, STR will be 180 degrees minus theta, and my reason is angles on a straight line. So if I want to work out what the length of TR is, here's TR and it's opposite 45, and I know that angle T is 180 minus theta, and that's opposite x. I can definitely use the sine rule. So with the sine rule, I use what I want on top, TR out of sine of 45 is equal to x out of sine of 180 degrees minus theta. So let's isolate TR by multiplying both sides by sine of 45. So I get x sine of 45. And I know from my reduction formula that sine of 180 minus theta is sine of theta. Now they said no calculator, so I'm going to use special angles. Sine of 45, 1 root 2. Sine of 45 is 1 out of root 2. So that means, therefore, TR is equal to x out of root 2 sine theta. Now, as a side note, there is another way to tackle this question, and the other way would be to work with this triangle here. So I'll do my working out here on the left. I'd start off by saying QR is equal to x, and then my reason would be sides of square. And then I can also use the sine rule because I've got this pair here and this pair here. TR is TR over sine of 45 is equal to x out of sine of theta, and you land up in exactly the same place. X times sine of 45 over sine of theta, and I know sine of 45 is 1 out of root 2, so x out of root 2 sine of theta. So you could have used either of the triangles, either TSR, that was here, TSR used with this answer, or you could use TQR, and you wouldn't be using the reduction formula, but you'd have to state that missing side. So let's finish up this question. We've already done 3.2.1 and 3.2.2. And remember, if you couldn't get the answer for 3.2.2, you can still use the fact that you're supposed to find in 3.2.2 that x, or that TR, is x out of root 2 sine theta. So now it tells me how much TR is. So remember, TR is this length here. It tells me that TR, so we're on 3.2.3, it tells me that TR is 3x out of 4. But in the previous question, I know that TR is x out of root 2 sine theta. So that would be x out of root 2 sine theta. Now I want to find out the size of theta, so I'm solving for theta. So at the moment, the way things stand, sine of theta is in the denominator. So let's multiply both sides by my lowest common denominator, which will be 4 root 2 sine theta. So on the left, I'm going to get 3x times by root 2 sine theta. And on the right, I'm going to get x times 4, or 4x. Now remember again what I'm trying to solve for. I'm trying to isolate the theta. And the way I'm going to do that is by isolating sine theta. So I'll need to divide both sides by the coefficient of that. That's this. So I'm going to get sine of theta is equal to 4x out of 3x times by root 2. Or I could have said, maybe a little bit more neatly, would be 3 root 2x. Now normally we don't divide by variables and remove important information. But in this case, I'm not trying to solve for x, I'm trying to solve for theta. So the fact that I've divided those x's and they fall away doesn't really matter to me. So now I can work out what theta is, and I'll get theta is going to be shift sine of 4 out of 3 root 2. And I get, when I work that out in my calculator, 70.53 degrees. Now remember, when you're using the sine rule, you need to consider, do you have an ambiguous case or not? Now at the moment, if I was to work in QTR, I know angle 45, and I know the side length x. I only know an angle and a side. The last angle I was trying to work out. So I definitely don't have a case for congruency. So I could possibly have an ambiguous case. So my other option would be 180 degrees minus 70.53. And you get 109.47. And let's see, if I said 109.47 plus 45, I know that's definitely less than 180, so there's still room to work out angle R. So For this question, I'll have two possible angles for theta. In question 3.3, you're asked to prove the sine rule. Now, whenever you go into a test or exam for trig, you need to learn the proofs for the sine rule, the cosine rule, and the area rule in both grade 11 and grade 12. It's easy, free marks to get. If you learn the proof, you're guaranteed full marks for this question. Let's go through the proof quickly. I'm going to move the sketch up a little bit so I have more space. The first step of the proof is to construct a perpendicular line. So let's add another letter. Let's make that A. Construct ZA perpendicular to XY. You must state this construction. If you have a diagram sheet or you have an answer book, it's also good to draw that in to your sketch. And let's call this piece H. So we're going to say ZA is equal to H because it's the height of my triangle. So the way that the sine rule works, or the sine rule proof works, is I work with the triangle on the left first. In triangle XZA, from this angle, because that's the angle I'm aiming for, sine X, sine of X will equal to H over Y because it's opposite over the hypotenuse, and I'm going to make H the subject of my formula. H is Y sine X. Then I'm going to work in the triangle on the right. And in the triangle on the right, I'm going to work with angle Y. Again, this is opposite, and X will be the hypotenuse. So in triangle ZAY, sine of Y will be opposite over hypotenuse, and I'm going to make H the subject of my formula, X sine Y. Now both of these formula have H, so I can equate them. Let's make this 1 and make this 2. Therefore, 1 is equal to 2. So Y sine X is equal to X sine Y. I'm going to divide both sides by XY, and I get therefore that sine of X over lowercase x is sine of Y over side Y. Like I said, this is something you can prepare before an exam and look for the proof in your test or exam and do it, and you'll always be guaranteed these marks. At the end of the question paper, there was a challenge question relating to question 3.2. Now, many students did not attempt this challenge question because it was not for marks. However, it's still worth looking at the question after the test, just to broaden your mathematical knowledge and to see another way of doing something. So let's take a look. In question 3.2.3, if ST is equal to QT plus RT, so let's quickly see where these are. ST is this line, QT is this length, and RT is this length. So in other words, ST is the same as TR or RT plus QT. So let's add that onto my sketch for now. Let's make another letter. What letter hasn't been used yet? PQRST. Let's use U. So I'm going to say that TU is equal to TR. And so I'm doing constructions. And I'm going to join UR. So there you go. That's joined. Now remember, the purpose of this question is I want to work out what is the size of theta. Now at the moment, I have an isosceles triangle TUR. So I know the angles opposite equal sides will be equal, but I need a bit more. Let's look at the two sides, or the two triangles on the outside. Remember that SU is equal to QT because ST is made up of those two lengths. Now in these outside triangles, here I've got this one and this one. Remember that this side length is X. I can say in triangle SUR and triangle QTR, surely the triangles will be congruent. Number 1, SR is equal to QR, sides of square. Number 2, QT is equal to SU, given. And number 3, I've got those angles of 45. So I've got USR is equal to TQR is equal to 45 degrees, and my reason would be diagonals of square. Therefore, triangle SUR is congruent to triangle QTR, and my reason is side angle side. Therefore, I know that angle SUR is equal to theta. Now remember from earlier, we said that the angle inside at UTR is 180 degrees minus theta. But I also have that angle U, so angle TUR, will be 180 degrees minus theta, and my reason will be angles on a straight line. And since I've got angles opposite equal sides, each one will be 180 degrees minus theta. Just fix that mistake I've made there. So we know that that will equal to TRU, angles opposite equal sides. And since all my angles are equal, surely each angle will equal to 60 degrees, which means that theta must be 120 degrees. The purpose of working through this challenge question is to expose you to something different. You may have got that theta is 120 a completely different way. Or you may think to yourself, I could never work that out myself. Don't despair. For this question, you might just have enjoyed looking at the solution and saying, wow, that's an interesting way of doing things. And don't feel too stressed if you didn't get there. Or you might be in the place where you like these challenge questions, and it might spark you to try some harder things.